So example 4, comparing linear functions. The earnings Y in dollars of a nighttime employee working X hours are represented by the linear function Y equals 7.5X plus 30. The table shows the earnings of a daytime employee. For 1 hour, they get $12.50, 2 hours, $25, 3 hours, $37.50, and 4 hours, $50. Which employee has a higher hourly wage, the nighttime employee or the daytime employee? Well, think about your two people. So one person has a function that's represented in the form of an equation. Remember, we talked about this in the last lesson where you can represent a function in many different ways, one of them being an equation, the other being a table. So the nighttime employee is represented here with this function. So this one's nighttime. And then you have the table here which shows the daytime employee. So they want to know which employee has a higher hourly wage. What do you think you can do to figure this out? Many of you probably already have the answer in your head. So remember that the slope of a function is always a rate. And then your y-intercept here is always your one-time thing, right? So this nighttime employee makes $7.50 an hour plus some flat fee of $30. Who knows what's that for? Maybe just for showing up to work that day. So, or it could be their bonus because they're willing to work a nighttime shift. However, they are asking about the hourly wage. So the nighttime employee makes $7.50 an hour. And the daytime employee, if you look at the 1 hour here, they're making $12.50. So who has a higher hourly wage? The daytime employee. B. Write a linear function that relates the daytime employee's earnings to the number of hours worked. In the same coordinate plane, graph the linear functions that represent the earnings of the two employees. Interpret the graphs. So here, the book actually graphs the two equations for you. I'm just going to assume that you know how to graph because it's from a previous lesson. And remember, if you forgot and you just want to see what it looks like, you're always welcome to use Desmos.com, the graphing calculator. So the blue line here represents the earnings of the nighttime employee, and the red line represents the earnings of the daytime employee. It wants you to interpret the graphs. Here it says, use a verbal model to write a linear function that represents the earnings of the daytime employee. So remember, the daytime employee starts at 0. There is no y-intercept, but you know from the previous slide that they're earning $12.50 an hour. So it does make sense that y, their earnings, equals their hourly wage, which is 12.5 or $12.50 per hour. And if you remember from a previous chapter, this here does represent a direct variation or proportional equation. And we remember that those always start at the origin. Here it says the graph shows that the daytime employee has a higher hourly wage, but does not earn more money than the nighttime employee until each person has worked more than 6 hours. So it's interesting to see that the earnings of both the nighttime and the daytime employee are the same at 6 hours. Okay, so before 6 hours, who's actually earning more money? The nighttime employee. After 6 hours, who's earning more money? It would be the daytime employee. So let's revisit our essential question. How do you write a linear function given a table or graph? Think about some of the examples that we went over today. How would you explain to somebody how to write a linear function if you're given a table? How would you explain those steps when given a graph? Go ahead and take a few minutes to answer this essential question in your summary section.